Hello everyone, welcome back to Theory Deviations. So as you may have guessed, in today's video we are going to be doing another example with the substitution rule. I'm going to be making some shorter videos in the future, just covering some more examples of the substitution rule with me to explain it. Now of course we have our daily integral playlist, which shows solutions to the integral, but I'm not narrating, so maybe these will be a little bit easier to understand if you are new to the subject. But of course, once you get the hang of it, it gets pretty easy, and then you can always rely on the daily integral videos just to help you out in the future. So the substitution rule, as far as we've covered it, we did one example in the intro video, and then we did another example last time. And in both of those examples, when we received our du after we differentiated, we could substitute that directly back into our integrand. Well, we will see in this example a case which is the more popular of cases that we have with substitutions, where we will need to manipulate the du so that it will match our integrand better than it would otherwise. So let's try this example. So we're going to integrate negative x times e to the x squared dx. All right. So immediately what I see about this is I see that I have an operator function. So I have an exponential, so I have e to the something, and that something is x squared. So a natural choice for my u substitution is going to be this x squared, because if you notice here, elsewhere in the integrand, I have a negative x. And really what's important about this is that it's some x to the first power, because when I differentiate x squared, I get 2x. But the important thing is that 2x is a first degree monomial. And that's what's important, because we can do some manipulation later on, and we'll see how that works. All right, so now what we can do is we can find our bracket. So again, as I said, this 2x is going to be this x squared is going to be a natural choice for our u, because we see something to the first power elsewhere. And of course, differentiation is a power reducer. It reduces the power of your function. All right, so here is our bracket for our u and du. So here we have u equals x squared, no surprises there. Du equals 2x dx. Again, that's simple differentiation, then we always tack on the differential at the end. Now what we need to do is this 2x, we don't have a 2x in the integrand, but if I do a little bit of manipulation and play around with some constants, I can make something look like this negative x dx that we have in the integrand. So to do that, what I'm going to do is I'm going to solve for negative x dx. I'm going to try to make this expression look like negative x dx. So I have something in terms of u equal to something in terms of x, right? So if I multiply both sides by 1/2, or by negative 1/2, I will get negative 1/2 times du equals negative x times dx. And this is exactly what we're looking for, because this goes right into our integrand. This is what's in our integrand. So we can substitute this into the integrand, and we will be left with something that's both able to be integrated and also something that is easy, something that is in the table, in fact. All right, so now we are left with negative 1/2, because we can pull out the constant, times e to the u du. All right, now this is got to be one of the easiest integrals you've ever done. E to the u, e to the variable, is e to the variable, and of course then we're multiplying it by that constant that we had outside. So we get negative 1/2 times e to the u. All right, so now all that's left is a little bit of back substitution. Now we need to plug in our x squared back into our u. So that's going to give us negative 1/2 e to the x squared plus c. All right, and now of course we can make sure that we got this answer right by differentiating. So in order to make sure that we got the answer right, we can do a little bit of differentiation with the chain rule, and then you will know that you got your answer correct. Actually, what I suggest, if you want to look for some practice on your own with these integrals, try taking a function and differentiating it, a function that would require differentiation by the chain rule. Then differentiate that and try to integrate it back to get your original function. That's one way I like to test myself to see if I'm good enough with U substitutions. All right, now in the next video, we're going to do another example. We're just going to keep cranking these out until we're done with Calculus 1, and that should be in about, I don't know, 5 or 6 videos. So we will see you guys in the next one for another example with a U substitution.